Okay, so circles now. Now the first thing we need to do is make sure we write it in the form for the equation of circles. At the moment, unfortunately, we don't have it in that form. Okay, so we need it in that form. So what we're going to have to do is we're going to have to, and it's going to be like completing the square here, get it looking like this. Okay, so we know we've not got the coefficient of x squared that isn't 1, so we're fine just to start a bracket off here, write down the x, put a squared there. Now at the moment, if I have another bracket here of x, when I times it, I'll get the x squared. Okay, and now I need to think, what term do I put here? So when I times this expression by the same expression again, because remember, you're squaring it, you'll be timesing it by the same expression. I need to think of how I'm going to do this so I get a 4x. Well, if I put a plus 2, so if I just have half the term here, I will get the 4x that I want. Okay, so when I do x plus 2 all squared, I will get an x squared term, I will get two 2x terms, which give me 4x, but unfortunately what's going to happen is I'm going to do 2 times 2, because that's the 4th term that I'll get, which gives me an unwanted 4. So to counter that, I'm going to take away the 4. Now whilst it doesn't look the same, it actually is. X plus 2 all squared minus 4 is the same as x squared plus 4x. So now let's deal with the y's. In the bracket I have y minus 1. So yet again, I want to make a y squared, and I also want to make a minus 2y. But also when you square that out, you'll get minus 1 squared, which is just 1. So take away 1 to deal with that. And then just remember, we've also got a minus 11 there as well in the original equation. So now I've got my x plus 2 squared, I've got my y minus 1 all squared. Okay, so it's now starting to take shape, it's starting to look like the equation of a circle. I've got a minus 4, a minus 1 and a minus 11. If I add 4, 1 and 11 to both sides, and we get 16 on the right hand side, and I get rid of all the numbers here on the left hand side, because if you look, I haven't got any constant terms outside these squared brackets on the left hand side for my equation of a circle. So I've got it in the correct form now. All I have to do is find the centre. Now the centre, when it's in this form, is at AB, but if you look at the equation, it's minus A here and minus B there. So if I've got a plus 2 there, that means A is going to be, let me just go back and delete that. So if I've got, I'm looking for the centre, it's going to be minus 2, so not positive 2, it'll be minus 2, and then for the y coordinate it's just going to be 1, okay, because it's already in the form y minus a number, and that's what my equation of a circle is, whereas this one I had a x plus something, whereas my equation has x minus something. And then just the radius, let's call it r, the radius is 4, it's not 16, it's 4, because the 16, that's the r squared, but I just want the radius, so I don't want the radius squared, I just want the radius, so just square root of 16, which of course is 4. So I want to now find the coordinates of the points where C crosses the y-axis, given your answers in simplified surds. Now I'm going to refer to what I just wrote down here. So write down x plus 2 and y minus 1 all squared, and that equals 16. Now really important that you remember, if you're looking at where a line or a curve crosses the y-axis, so it crosses the y-axis when x equals 0, okay? So imagine that y-axis, okay? is going up vertically. All the x values on there are just 0. So all we're going to do is sub in x equals 0. So we put it in this bracket here. We're just left with the 2. So you're just left with a 2 squared. And then we've just got the y. Then 2 squared is obviously just 4. So take 4 from both sides. And we're just left with this. Now what I'm going to do is I'm going to square root both sides, and I'll get rid of my squared term here. If you'd like, you can expand that bracket on the left hand side, but all that's going to happen is you're not going to get, you can rearrange it in the form ax squared plus bx plus c equals 0. You'll get a quadratic, but you won't be able to factorise it. It's good, you know, the fact that you've got to leave it in simplified surd form should make you think you're not going to be able to factorise this very easily. So really, it's, you know, completing the square you're going to have to do anyway, or using the quadratic formula. But why do that? Because if you complete the square, all you're going to do is end up with something in this form anyway. So once I've got in this form, it's so much easier just to square root both sides. If I square root both sides, I'm just left with y minus 1 on the left hand side, and then I've got root 12, but remember I'm going to have a positive and a negative solution here. Add 1 to both sides and I get the following, but we must leave it in simplified surd form. So simplify the root 12. 3 times 4 makes 12, so that's root 4 times root 3 makes root 12. Square root of 4 is just 2. So our coordinates would be, remember we did this for x is 0, coordinates is 0, 1 plus 2 root 3, and the other coordinate is 1 minus 2 root 3. The first part of this question was generally answered quite well. Okay, if I'm showing a transformation of f of x, if I'm doing transformation of y equals f of x plus 2, I think most people remembered that, well, actually you might think it goes to the right because it's plus 2, but actually it doesn't. It goes towards the left, okay? So you've got something inside the bracket. It doesn't necessarily always do what you think it would do. So plus 2 inside the bracket just means that you need to translate everything to the left. So the root, where it was minus 3, now becomes a minus 5. The root that was 1 just becomes a minus 1. So you just need to take 2 away from all the x values, and you'll get minus 5 and you'll get 1. Okay, the shape of the curve will still be the same, and we're only asked to show where it meets the x-axis in this one. So we've got our roots on there. Now just remember, it's just a translation, so the shape just translates to the left. So this turning point here on the axis is still going to remain, okay, but now it's just shifted from minus 3 to minus 5. Okay, so don't have it going through here and then back onto the x-axis. Okay, it's turning at that point, so make sure you keep that turning point in, and then it goes straight through x equals minus 1. I'll just make that clear. If it's, I think my curve's just gone through that minus that originally drew. Okay, so that's minus 1 there. Okay, and that's 3 marks. Okay, so get your right roots on there, make sure you're showing that it's a shift to the left. Okay, it doesn't ask you for minimum points, but you could, if it did, make sure you say this is minus 2, minus 9, this point here. So you could also say what point that is, not that you're actually asked to in this one. There we go. So part B of this, we're going to write down the equation of the curve. So if we're, no, it's only 1 mark question, so you can't expect to do too much for this one. So all we need to do now is 2 ways you could do it. You can look at your answer for part A and then say, well, now the root, the turning root's the at minus 5, and the other route that just goes, the curve just goes straight through, is at -1. So therefore you need to change what's in your brackets here to reflect that. The other thing you can do is just, this is f of x, so if you put in f of x plus 2, just replace all your x's with x plus 2. So in the first bracket here, this is going to be x plus 2 instead, so x plus 2 plus the 3 will just be 5. First bracket will just be x plus 5 all squared, and second bracket, well, 2, you just have x plus 2 minus 1, 2 minus 1 obviously being 1, and you'd have the following, and that's it. That's all you need to do, and that fits in with what you've got for your roots here, because you've got a root of -1 and a root of -5, and those solutions, those solutions would work if you set this to 0. And then part C, so it says using your answer from part B, find the coordinates of the point where the curve C meets the y-axis. Okay, so we've sketched curve C. It's not asking about our original curve. This is asking curve C, the one that we drew here. So we're going to find out where it crosses the y-axis. And remember, it's going to cross the y-axis hopefully you're all shouting it out at your computers at home. Crosses the y-axis at x equals 0. Really important you remember that. So sub it in here, sub it in both brackets here. We've got 5 squared, because we're just going to have 0 plus 5, which is just 5. 5 squared in the first bracket, and we're timesing that. It's just 0 plus 1, so we just times that by 1. Make sure you times them, not add them. Okay, common mistake people made was to accidentally add these instead of times them. And 25 times 1 is obviously just 25. So the coordinates is just going to be 0, 25. That's where it will meet the y-axis.